Hello everyone. Welcome to my continuation lecture number 5. And this lecture is related to xenobiotic and its metabolism. Today I will just highlight the basic points or the factors which affecting the biotransformation of drugs. What are the different factors that affecting the biotransformation of drugs? Before administration of drug or co-administration of other drugs. Or prior administration of the drug or co-administration of other drugs, so it will directly affect the biotransformation of drug. The same case as with drug-drug interactions. Sometime whenever we are going to mix the two drugs with each others, so during mixing there may be chances of incompatibility. So it's the same case as here. Co-administration of other drugs, so it will directly affect the biotransformation of the drugs. Diet play very important roles which can also affect the biotransformation of the drug. So as we have already discussed that the absorption is high on empty stomach. But the absorptions on full stomach, that is low or incomplete. So diet also play very significant roles. Diet is one of the contributing factor that affecting the biotransformation of the drug. Hormonal status, it can also affect the biotransformation of the drug. So as we know, there are different, for example, whenever there are certain type of abnormalities which is occur at hormonal levels, so it will definitely affect the biotransformation of the drugs. Genetics can also affect the biotransformation of the drugs. Disease state, in any disease condition, so it will decrease in cardiac and pulmonary disease. So I mean that the biotransformations of the drugs, it will be affected by the different type of diseases. Age and developmental status, so it can also affect the biotransformation of the drug. The functional status of the liver and kidney, for example, if your kidneys are functional, so it means that the drug will be strongly biotransforms, while in case of if your kidney and liver, if they doesn't work properly, so definitely the biotransformation process of the drug will be affected. Furthermore, in phase 1 reactions, which include the oxidation reaction, reduction reaction and hydrolysis reaction. So I will explain each topics one by one. They are also called hydroxylation reactions. Since they introduce or expose a functional group, for example hydroxyl group, OH group, that serve is the active center for the sequential conjugation and phase 2 reaction. So if you remember that by changing the functional group in any compound, so it will change the physico-chemical property of that particular compound. So the same case is here, that they are also called hydroxylation reaction. So by exposing the functional group like hydroxyl group, so that can serve, so it is the active center for the sequential conjugation and phase 2 reaction. Now In phase 1 reaction, how the oxidation reaction take place. So you know that oxidation, a large number of foreign substances, they are destroyed by oxidation in the body. So there are some foreign bodies, large number of foreign bodies, which are devastated or destroyed by the oxidation in the body. So look at the example of oxidation of methyl group containing compounds. For example, you have different compounds and that compounds contain methyl group. So how the oxidation reaction can take place here? So methyl group, it is oxidized to acid through the formation of alcohol and aldehyde. So look at here on my screen, CH3. So this is methyl group, and this methyl group, this is oxidized to acid through formation of alcohol, and this as ethyl alcohol. So ethyl alcohol is formed, mean that one hydrogen, that is, look at here, CH2 OH, and then further CHO carboxylic acid, CHO, and this one is carboxylic acid, and this one is aldehyde. So the methyl group is oxidized to acid through the formation of alcohol and aldehyde. This is clear. This one is methyl, and then this is ethyl alcohol, and this one is you can say carbohydrates, aldehydes and ketone, but this is actually aldehyde, which contain carbon, hydrogen and oxygen. So if you remember in the definition of carbohydrates, which contain carbon, hydrogen and oxygen, so carbohydrate, it may be aldehyde or ketone group of compounds, and this one is carboxylic acid. So this is also one of the functional group. So the main thing is how the oxidation of methyl group, so that is occurs, so oxidation of methyl group containing compound. Okay, furthermore, how the oxidation of alcohol occur. So the primary aliphatic and aromatic alcohols which contain benzene ring, they are oxidized to corresponding acid. Now let's see this order. Methanol is converted into formaldehyde, and then formaldehyde is further converted into formic acid. This one is methanol. So it means that methanol is converted into formaldehyde, while the formaldehyde, they are further converted into formic acid, while the ethanol is converted into acetaldehyde, and then the acetaldehyde is converted into acetic acid. The third one is benzyl alcohol. So the benzyl alcohol is converted into benzaldehyde. So, and then benzaldehyde is converted into benzoic acid. Now you can see here, this one is methanol. It means that alcohol group is present. The methanol is converted into formaldehyde. So this one means that alcohol is converted into what? Aldehyde, and then aldehyde into corresponding acids. Is the same case is here in ethanol, which is converted into acetaldehyde, and then acetaldehyde is converted into acetic acid, and benzyl alcohol is converted into benzaldehyde and then into benzoic acids, corresponding acid. Okay, now come to our methanol toxicity. So methanol toxicity, methanol has a relatively low toxicity. That's why it is used on a commercial scales. There are certain drugs like methanol. So methanol that is metabolized in the liver, and the first step of degradations, the methanol is transformed to formaldehydes by the enzymes, the alcohol dehydrogenase. So I mean that how the methanols is transforms into formaldehyde. Now look at here. Here the methanol is converted into what? Formaldehyde, with the help of enzyme that is called dehydrogenase, and then formic acids. The transformation of formaldehyde to formic acid by the enzyme aldehyde dehydrogenase is faster one. I mean that how this methanol the methanol is converted into formaldehyde with the help of enzyme, and then again the formaldehyde will convert it into what? Formic acid. And the enzyme which is involved, that is aldehyde dehydrogenase, the metabolism of the formic acid, that is very slow. This it often accumulates in the body, which results in metabolic acidosis. Now here I'm just going to explain the fundamental mechanism that how the metabolic acidosis occur. So in first step, the transformation of formaldehyde to formic acid with the help of enzyme which is called aldehyde dehydrogenase is faster, and the metabolism of formic acid is very slow. Why the metabolism of formic acid is very slow? Because these formic acid, they can accumulate on your body. Consequently, the metabolic acidosis occur. The major damage which is occur to optic nerve. Optic nerve is damaged here. The ethanol is given as a antidote. You know, the most commercial product, the most commercial chemicals which is used in different industries. Since it is true that the substrate of the aldehyde dehydrogenase and methanol is spared. This is somewhat the methanol toxicity which is very low. That's why it is very commonly used in on commercial scale as well as on small scale. Now look at this example. This is the example of entoxification. And entoxification, this is methanol, and methanol, the carbon is attached with 3 hydrogen with hydroxyl group. So with the help of alcohol dehydrogenase, this methanol is converted into formaldehyde, and this formaldehyde is actually the carbon is bonded. There is a double bond with oxygen and 2 hydrogen atoms with carbon. So the methanol is converted into formaldehyde with the help of alcohol dehydrogenase, and then further the formaldehyde will be converted into the formic acid with the help of enzyme which is called formaldehyde dehydrogenase, because without enzymes the reactant species, they are unable to proceed, or the reactants, they are further converted into products. Okay, furthermore, when the formaldehyde is formed and with the help of formaldehyde dehydrogenase, it is converted into formic acid. So formic acid contain carbon with 1 hydrogen with 2 hydrogen and 2 oxygen atom with double bond with oxygen. So after that, the metabolic acidosis and tissue injury occur at this place. So if you remember, in metabolic acidosis, so I have mentioned here that there will be the transformation of the formaldehyde to the formic acid, and the enzyme which is involved, that is aldehyde dehydrogenase, which is faster, but the metabolism of the formic acid is slow. That's why it can accumulate in your body and metabolic acidosis is occur. Okay, so the final product is the carbon dioxide gas will release and water molecules they are formed, and this is the classical example of intoxications. So inshallah, in my next lecture we will explain the oxidation of the aromatic hydrocarbon, that how the oxidation reaction that is take place in aromatic hydrocarbon which contain hydrogen, carbon, and as well as benzene ring, so I mean phenol. So inshallah I will proceed this lecture. Thank you so much for watching this lecture. So if you have any question regarding my present lecture, so you can directly contact me, and I am available for any kind of services. Wish you best of luck. Thank you.